Topic 3 is entitled Polynomial Functions. In some sense, these are the most basic functions in the course, but they are also the most important. Indeed, the history of algebra is all about the discoveries our ancestors made while attempting to solve polynomial equations. Constant functions, linear functions, and quadratic functions are all examples of polynomial functions. The fundamental theorem of algebra, which extends well into advanced mathematics courses, is about polynomial functions. The topic begins with a review of the vocabulary of polynomials, which most students will recall from Algebra 1. Students will also review the basic behavior of polynomial graphs, which involves more vocabulary. Today's students can produce polynomial graphs easily on their graphing calculators, and the resulting visualization of how they behave is a great tool for comparing and understanding these functions. Students then add, subtract, and multiply polynomials to get new polynomials. The fact that polynomials form their own algebraic system is more profound than Algebra 2 students might realize right now, but it is a good review of algebra skills, and it lays the foundation for the concepts that lie ahead. Students then move on to a review of some algebraic formulas related to factoring, here called identities, as a bridge to the trigonometric formulas that students will encounter later in the course. Since most of the factoring formulas involve binomials, the binomial theorem is included at this point. This allows students to see how the coefficients of a binomial expansion can be found along a particular row of Pascal's triangle. Students then learn how to divide a polynomial by a binomial, first by the long division algorithm, and then by the streamlined version known as synthetic division. This prepares them for the remainder theorem and its important special case, the factor theorem. Although the factor theorem seems pretty simple and obvious, it is actually one of the most significant theorems in the history of algebra, since it has always been the key to solving polynomial equations. The roots, or solutions, of a polynomial equation of the form p of x equals 0 have an important connection to the graph of y equal p of x. The roots of the equation are the zeros of the polynomial, and the real zeros are exactly the x-intercepts of the graph. This connection is studied closely in the middle of the topic, at which point students are also introduced to the idea of the multiplicity of a zero and how it affects the behavior of the graph. Students then move on to some of the most profound and important theorems in the history of algebra, including the aptly named fundamental theorem of algebra. In truth, these theorems are no longer necessary for solving polynomial equations, since technology can do it faster and far more easily, but they are still conceptually important for understanding how polynomial algebra works. It is useful to approach these theorems from a historical perspective. How did scientists solve equations before they had technology to crunch the numbers? Well, they used the rational root theorem to narrow their search, then did the factor theorem and the conjugate root theorems to simplify the problem, and eventually the fundamental theorem of algebra to know when they were done. That's an oversimplification, of course, but not bad for one lesson. Students are then introduced to odd and even symmetry, a general function topic that is most easily understood when applied in the context of monomials of odd and even degree. Students can then analyze the symmetry of other kinds of functions later on. The topic concludes by revisiting function transformations in the context of polynomials. It's an interesting fact that all linear functions can be interpreted as transformations of the single parent function y equals x, and all quadratic functions can be interpreted as transformations of the single parent function y equals x squared. Single parenthood does not suffice for generating all polynomials of degree 3 or higher, but it is still instructive to look at their transformations.